All right, this is lesson 7-2. We just went over ratios and proportions in chapter 7. Now we're moving on to similar polygons. And we're going to get more specific than the next lesson, similar triangles, but we're focusing on just shapes in general, polygons in general, and whether or not they are similar in this lesson. So similar means proportionate, right? If you start off with a right triangle, all you need to do to find a similar triangle is either enlarge it or shrink it, but you're not changing the shape at all, right? So you're going to have a scale factor, which tells us by how much to increase it or decrease the size. And all we're doing is comparing. So that's the basic gist, right? The shapes, goodness, there's birds freaking out outside. The shapes they're the same shape. We don't change anything about them. A right triangle wouldn't turn into an obtuse triangle, right? It still stays a right triangle. We just either proportionately enlarge it or shrink it. Okay, it's the same size. All right, so if triangle ABC is similar to this little squiggle right here, it looks kind of like the congruency symbol over the equal sign. It looks like a backwards sideways S, right? It means similar, this one little symbol. This guy means similar. Don't forget that. If triangle ABC is similar to triangle XYZ, list all pairs of congruent angles and write a proportion that relates the corresponding sides. What? A proportion is a ratio, right? It's when we set ratios equal to each other. Remember a proportion, like 2/3 is equal to whatever, 4/6, or that's a proportion. You set two ratios equal to each other. So use the similarity statement. Congruent sides here, it tells us they're A and X. If these two guys are similar, then just look at the positioning. A is the first letter, X is the first letter. So A is not congruent. Sorry, I shouldn't have done that. They're not necessarily congruent to, well, yeah, these are congruent. The angles are congruent. The sides are not congruent. Okay, so A and X are congruent to each other. B and Y are congruent to each other. And C, 1, 2, 3, and Z, 1, 2, 3, are congruent to each other. So when the angles are all congruent, I know it's a similar triangle. I either just made the sides bigger or made them smaller, but I didn't change the angle, so it's a similar shape. Proportions, that's our little equal triangles, right? So we're going to write a proportion statement with the sides. Okay, so for ABC is similar to XYZ, the first two letters here are AB, so then the corresponding side in the second triangle would be the first two letters here, XY. Okay, so basically they're talking about triangle ABC on the top of each fraction or ratio, and triangle XYZ on the bottom of each ratio, okay? So side AB in the top triangle, AB, has a relationship or is corresponding or similar to side XY, okay? Which is equal to, it has the same ratio or the same scale factor as in the top triangle, side BC. It's corresponding to, BC is the last two letters, YZ is the last two letters. So BC and YZ. And then the third side is CA. We took the last letter and put it with the first. So we take the last letter, put it with the first, ZX. So CA and ZX. Right? The ratio of the first triangle to the corresponding side in the second triangle should be the same in all of these. We're comparing corresponding sides, but if the triangles are similar, which means they're basically the same, we just either shrunk or enlarged one, then the ratio of their sides should all be the same. Now, it doesn't tell us what the length of the sides are, so we can't do any math yet, but that's how we write a proportion statement. We're just comparing the sides. Okay, and we'll have more practice doing that too. All right, so step one, compare, let's do an example here, sorry. Determine whether the pair of figures is similar. If so, write the similarity statement and scale factor. Scale factor is if they actually give us numbers, like up here, if they had actually given us numbers, we wouldn't just write AB over XY. We would write the length of side AB over the length of side XY. So if this was a 2 and this was a 4, we would write 2 over 4. Okay, so when you don't have numbers, you just tell the name of the line. When you do have numbers, you actually tell the measure of each line. You give that number there, okay? And once you simplify that fraction, that ratio, that's your scale factor. If two shapes are similar, then all of the corresponding sides should have the same scale factor. If they do not have the same ratio, the same scale factor, then they are not similar shapes. It means one of them you did more to it than just shrunk or enlarged it. Okay, so for step 1, here I'll try and zoom in just a little bit there. It's hard to see. Step 1, compare corresponding angles. Okay, so here they are already marked corresponding to us. So we know W and P are corresponding, X and Q, Z and S, Y and R. So we would write all that out. And the angles have to be congruent. The side lengths won't be congruent, but the angles will have to be congruent. So P and W are congruent, X and Q are congruent, Y and R are congruent, Z and S are congruent. Corresponding angles are congruent. Fantastic. They're all marked that way. Compare corresponding sides. So now we're going to look at the sides, right? So they started off with WX in the first shape here, WX. This side is corresponding to PQ, right? And WX, it tells us, is 12 and PQ is 8. So they wrote WX over PQ, 12 over 8. Awesome. And then when we simplify that, we can divide the top and the bottom by 4. We get 3 over 2. So for every 3 units in this triangle, there's only 2 in this triangle, right? This triangle, quadrilateral. This quadrilateral is 1.5 times bigger than this guy. 3 over 2 times bigger than this guy. For every 2 of these, there's 3 of these. That's all we're saying. Okay, so then X, Y, and QR. That's this side and this side. XY to QR should be the same ratio as WX to PQ, right? So XY is 18, QR is 12. If I write 18 over 12 and simplify, I get 3 over 2. So far, so good. They're the same scale factor. Okay, YZ to RS, that's this bottom and this bottom. 15 over 10. If I simplify, divide the top and the bottom by 5, I get 3 over 2. And then lastly, ZW and PS or SP, right? And that's 9 over 6, which when I simplify that ratio is 3 over 2. So when I compare this first shape side to the second shape side, the ratio of this side to this side is always 3 to 2. This one's a little bit bigger than this one. If I took this side and multiplied it by 3 over 2, I would get this side, right? So here's our scale factor. Scale factor. The polygons are similar with a scale factor of 3 over 2. And if we were comparing it here to here, 3 over 2, but we could have compared it to the second one to the first one, here to here, that would have been 2 over 3, right? Usually it'll be specific on which way they want you to compare it. Compare this first one to the second one, that would be 3 over 2. If they said compare the second one to the first one, then that would be 2 over 3. Hopefully that makes sense. Okay, and that's what it's showing down here. Okay, so let's get into doing some exercises here. List all pairs of congruent angles and write a proportion that relates to corresponding sides for each pair of similar polygons. For this first 2, we don't have any numbers, so we're just getting the hang of coming up with corresponding sides. All right, so for number 1, triangle DEF is similar to triangle GHJ, right? So all the corresponding angles have to be congruent, and then the corresponding sides have to have the same ratio, okay? So D is the first letter here, and G is the first letter here. So angles D and G, this guy and this guy, are congruent, okay? And then the second letters are E and H. So this guy is congruent to this guy. And then the third letters are F and J. So F, 1, 2, 3, is congruent to J, 1, 2, 3. Okay, so basically it just looks like I kind of flipped this triangle over on its side. And it also looks like I enlarged it a little bit, proportionately, right? But it doesn't give me any numbers, so I don't know that yet. Okay, and then after we mark the congruent angles, this all pairs of congruent angles, I'm going to say angle D congruent to angle G, angle E is congruent to angle H, and angle F is congruent to angle J. I just listed it out in corresponding order here. D and G are the first two letters, E and H are the second two, F and J are the last two. Then I have to list the corresponding sides, right? So if I start out with this side DE, if I start out with these first two letters DE, DE is corresponding to the first two letters here, GH. So I'm going to write them in a little ratio. The side DE corresponds to the side GH. I don't know the sizes yet, but this is how I would write the ratio. Right, proportion. So that ratio should be equal to the next sides. So I had DE and GH. Now I'm going to go EF and HJ. EF, HJ. And that should be an equal ratio to the third side, which is last letter, first letter, FD. And last letter, first letter, JG. Right? So all I did here was compare DE to GH, and then EF to HJ, and then FD or DF to JG or GJ. Right? I'm just comparing corresponding sides. And I write each set of corresponding sides as a ratio. And if these shapes are similar, which it tells us they are, all the ratios should be the same thing. Okay, so we're going to do the same thing here. This is not a triangle now, so it's a little different. PQRS is similar to TUWX. So the angles would be angle P is congruent to angle T, because they're both the first letters. Angle Q is congruent to angle U. Angle R is congruent to angle W. And angle S is congruent to angle X. So those are all my angles that are corresponding and congruent, right? And I can mark them congruent here if I want to. P is congruent to T, Q and U, Q, U, R and W, 1, 2, 3, 1, 2, 3, S and X, 1, 2, 3, 4, 1, 2, 3, 4. It gets jumbled up doing that, right? And then we have to compare all of the sides. So I just do it looking at the order of the letters, right? So PQ is the first two letters. That's my first side, PQ. It's going to be similar to TU, which is these first two letters. Okay, so I'm going to say PQ and TU are a ratio because they're corresponding. QR and UW. RS and WX. And then the last side, which is SP. We take the last letter, put it with the first. SP and XW. Okay, so here is all of our corresponding sides and the ratio from one shape to the next of each corresponding side. They should all be equal, and this creates a proportion when you set ratios equal to each other. All right, so let's actually do some math now. Same thing, we got to do the same thing, compare the sides, but now we actually have numbers to go with it, right? Determine whether each pair of figures is similar. If so, write the similarity statement and scale factor. If not, explain your reasoning. All right, well, the first thing that jumps out to me here is that there's a right angle here, and there are no right angles here. This is a regular 1, 2, 3, 4, 5 pentagon, and this is not 1, 2, 3, 4, 5. It's still 5 sides, but there's a right angle here. There's none here. Okay, and I could figure out the measure of each of these angles. Remember that when we try and find the measure of the interior measure of angles of a regular polygon. I would do 180 times n minus 2, right? All divided by 5. 180 times 5 minus 2 all divided by 5 would give me the measure of each of these angles. I wouldn't know the measure of the side lengths, it doesn't tell me, but I could figure out the angles. But I know none of them are going to be 90. I'm sorry. And in this case, one is 90. So we're going to say not similar. Angle L is the only right angle. There's no other right angle that's similar to it, so I know these are not proportionately either the same size or bigger or smaller. All right, now let's look at this guy. Now, these get a little confusing to look at, but we're comparing this smaller triangle to this whole big triangle, right? So we got to break down the sides a little bit. These two sides are the same size. These two sides are the same size. And this bottom is double this guy, right? So this entire, if we call this little side PR X, right? Then this entire side PT would be 2X. And if we called this little side Y, this guy is congruent to this guy, so this is another Y, so this entire side would be 2Y. Okay, so why does that matter? Why did we just do that? Well, remember, we have to write a similarity statement and scale factor, right? So first I have to say what angles are congruent and then what sides are congruent. Actually, that's breaking down the smaller part, sorry. The similarity statement would be triangle PQR is similar to triangle. So PQR is the smaller one, so the bigger one would be PST. And how do I know they're similar? Well, I know angle P is congruent to itself, no matter which triangle it's used in, the smaller one or the bigger one. Angle S and Q are congruent to each other. Angle Q congruent to angle S. And angle R is congruent to angle T. How do I know they're congruent? They're marked congruent. It's super tiny, but they're marked that way. Okay? And then I can write proportion, right? So side PQ on this top smaller triangle, side PQ, is corresponding to this whole big side PS. And if side PQ is Y, side PS is 2Y. Right? And then I can also write PR compared to PT. PR compared to PT. PR is X, PT is 2X. And then lastly, I can compare QR and ST. And QR is 11 and ST is 22. So each of these ratios here, these scale factors, should be exactly the same, right? Well, are they? Well, if I simplify this guy, 11 over 22, divide the top and the bottom by 11, I get 1 over 2. If I divide the top and the bottom here by X, I get 1 over 2. If I divide the top and the bottom by Y here, I get 1 over 2. So my scale factor is 1 over 2. So my congruence or my similarity statement here is that this smaller triangle, PQR, is similar to the bigger triangle, PST. It means I just started with the smaller guy, I made it a little bit bigger, I enlarged it proportionately, so now I've got PST. How much did I enlarge it by? Well, the smaller guy is 1, the bigger guy is 2, right? So comparing the smaller guy to the bigger guy, that's 1 over 2. Scale factor equals 1 over 2. Right? For every one of these, there are 2 of these. This big triangle, all the measurements are double the smaller triangle measurements. Hopefully that's making sense. All right, stay tuned for video 2.